Hello, welcome to another Teacher Tobin tutorial. We're going to be looking at operating systems, which is part of topic 3, computers. The specification code is 3.2.1 and it's Edexcel GCSE Computer Science specification. So operating systems, there's a fair amount of vocabulary that we need to learn here, but let's just talk about what they are in general. There are different types of operating systems that you might be aware of. I'm sure that you're familiar with the idea of Windows, and you're probably familiar with iOS, which will be running on mobile Apple devices, and Mac OS, and there's another one. Linux has been, there are many different branches of this, and you can download, for example, Ubuntu or Linux Mint for general purpose computing, or for web servers, CentOS. But you probably interface with Linux a lot more than you think, even if you haven't heard of it. It might be powering ticket vending machines, ATMs, all sorts of other systems you might be interacting with without realizing it. However, from a sort of consumer point of view, your Android and your Mac OS are all going to be the popular ones, and of course Windows is still the most used. So what do operating systems do? Well, at the heart of an operating system is called a kernel, which is essentially like a program which controls the operating system. It's always in control of everything that's going on. It's like the heart, the brain of the operating system itself, and that's going to interface with your CPU and your memory and all your devices. And then above that, your applications. So the operating system is going to be handling and managing all of those processes. So one of the big things that it does is process management. Okay, process management. And there's quite a lot to unpick here. So the operating system will coordinate, it's a CPU, central processing unit, to schedule processes. So I'll put in here a little schedule processes. As we looked at the fetch, decode, execute cycle, we saw all those different instructions and all the data that's in our primary memory and our RAM. Well, who decides what happens first and what happens next? Well, there are lots of scheduling process, and they're waiting to be executed, and they're held in some sort of circular queue. And the CPU allocates each process let's put a time slice. And switches to the next process. And there are different ways that a scheduler might do that. So there's first come, first serve algorithms. So, okay, you were here first, I'll do your process now then. Just like let's say you're in a pharmacy or waiting for a doctor appointment and you just got there early, you got there first, and the other person's not there. Okay, come in. All right, you were first come, first serve, you come in. And then there might be another one called round robin, which is, I imagine you have a parent-teacher conference, and I'll put in here, same time allocated, and I'll put first come, first serve, so you can remember that. So round robin says, okay, each parent has got 5 minutes. When your 5 minutes are up, you're done. We've got lots of parents to see. It's not really fair for you to hog all the time. You just got to move on. So that would be the equivalent of round robin. And then there's also priority. So I'll use that analogy as well. Priority-based algorithms where, let's say, we've got 5 minutes per parent, but there's a child you really need to speak to. There's something important that's come up, and you just say, look, I need to give them 10 minutes, or I need to see them now. It's really important. Don't go anywhere until I've spoken to you. It might be that the antivirus software that's running on the computer has found something that it needs their attention, and it's saying, look, do not do anything else on this computer until we've checked this file, because there could be a bit of a problem here. So that's how a scheduler might work. But again, under process management, there's all sorts of things going on. There's also multitasking and or multi-processing. And that might be managing how processes could be done concurrently. And of course, that can only be done if you've got a multi-core processor. You have to have a multi-core processor to do that. So I'll put in brackets here, multi-core CPU. That's the only way that that's going to be working. If you've got just say a Core 2 Duo, then you can have multi-processing at the same time. They can be doing two different things identically at the same time, just concurrently, parallel processing. So there's going to be this system of a cyclical queue and the schedule all the schedules, process managements, the operating systems constantly be monitoring all those processes and deciding what needs to go first and what needs to go second, or how we allocate time to the CPU, and to make sure things don't get bottled up. A bit like having traffic wardens and traffic lights, just to make sure there's flow of traffic, so that everyone can get to work. So that's just one subsection of what CPUs do. What else do they do? Well, they deal with peripherals and devices. And a peripheral, I'll spell it, a peripheral, it's a fancy word, but it really can just mean something like a printer or a mouse or a hard drive, a keyboard. Okay, that is a peripheral. Anything that's interfacing with that computer that's physical is going to be a peripheral. So keyboards, monitors, and for example, there'll be device drivers. So device drivers, which isn't really much of a problem anymore, because, for example, at USB has a UPnP, Universal Plug and Play protocol, where most USB devices are just handled directly with generic drivers. So modern Windows computers can pretty much handle anything. Mac OS has got quite a good device driver library, but you might come across a time where you plug in an old printer and it just won't read it, and then you might get lucky finding an old device driver from the Apple website and try to run it if it's compatible with 64-bit hardware now. Anyway, I've faced this problem before, and I've found old drivers which still work on newer operating systems, even though they're not meant to be the legacy systems, but you need the correct driver for it. And that driver is going to say, let's just use this printer analogy. It might say, go to sleep. Nobody's printing on you. Let's stop wasting energy. Let's stop being on, and just wait for the next person to use us. So it will be controlling the peripheral, and device drivers can control multiple devices at the same time. I'll put so can control multiple devices. So there might be some generic drivers which can, like, let's say you've got a really fancy printer at school, and you might be able to plug it into a computer and get it to do some basic functionality. But if you really wanted the full potential of that printer, you might have to download its specific device drivers, which would allow all the other functionality that it can provide, all the scanning and duplex modes and everything else. So let's have a look at another feature of operating systems: file management. Okay, file management is another thing that operating systems need to do. So it will allow you to create, delete, move, save and copy files and allocate them to folders. And the important thing is here, you've got your root directory, which could be the same as a folder, you can call it folder, and you're going to have all these subdirectories from it, and it's going to essentially look like an upside down tree when you're done. So maybe, I don't know, this one's Photoshop, and then you might have all sorts of subfolders based on projects, and the way to remember it is an upside down tree. I think that's the best analogy to use it. It's a hierarchical structure. So let me just write that down if I spell it correctly. Gosh, English is tough. Hierarchical tree-like structure. I think that's the best way to remember it. And of course, you'll have all sorts of metadata stored in those files. It could be the size, modified, date modified, created, permissions for read and write access, to prevent conflicts, and access rights, all sorts of things like that, which is generally in Octel, which is interesting, which you don't need to know about, but base 8 counting when you have read, write and execute access on files. And finally, user management. Okay, so this makes sense if you're using these computers. Let's say in a school you've got one computer suite and you've got lots of people going into that computer suite to use, and it's one computer, one device, but it's needs to be able to decipher who you are, what your account is, with your username and password, and grant you different levels of access. Grant access, for example, could be admin or just user, generic user. Maybe students aren't allowed to look at processes and task manager or to look at certain websites, whereas administrators can. And it can monitor login activities and create console logs, so you can see everything that was done on the computer. So there's quite a lot to unpick here, and so let's look at some example questions then. An operating system controls the scheduling of processes. Describe how the operating system uses scheduling to allocate processor time. So there are a number of things, and we have to say at least 4 things here. So I'm going to abbreviate here. I'm going to say all processes held in a queue. Processes are prioritized. And you could say some of the algorithms like FCFS or round robin or priority based algorithms are used. I think that could help you with that argument. And then processes are allocated time slices, all right, based on priority, and unfinished processes go back to the queue. So I think there's enough information there to get our 4 marks there. And then you could say that time slice has, at that particular point if it's being processed, you can say exclusive use of CPU at that particular time. That should be enough, I think, to answer that. So 4 marker is quite a big one. So maybe you could then go into the different algorithms that a scheduler can use. You could talk about round robin, first come first serve, priority based. Probably stick with priority based. As long as you're saying 4 things, 4 marks. Question here, okay, one function of an operating system is to manage processes. Describe one way the operating system makes sure each process can use the CPU. So this is an easier version of that bigger question that we just did. So you could say a scheduler algorithm controls the processes. So I'm just abbreviating here. Again, time slice. And then you could say held in priority in order. And then again, incomplete processes go to the end. So that would be more than enough for 2. So it's an easier version of that first question. And give one other function of an operating system. This is easy. Any of the ones we just talked about: file management, user interface, peripheral management, and file management. Those are the key ones there to use. So again, lots to unpick there. A pretty big subtopic, lots of jargon, lots of vocabulary, but you're just going to have to. The way I would think about this is you use operating systems all the time. You use your phone, your iPads, your computers at home. Think about how you use them and what things they do. Like user management is quite straightforward. File management is quite straightforward to remember. Device peripherals is quite straightforward to remember. The one you really need to focus on here is process management and schedulers, and that's what you've really got to focus in terms of answering questions for the exam. Good. I'll see you in the next video.